Hello and welcome to the course Climate Hazards and Disaster Mitigation. Today we are going to discuss drought severity and frequency analysis. So what have we learned so far? We understood the fundamental concepts of droughts, its types, causes, drivers and impacts. We also estimated different drought indices which were derived from hydrometeorological data, and we presented their comparison. We also analyzed drought characteristics such as initiation, termination, duration, intensity and severity. Today we are going to understand the importance of drought frequency analysis. Similar to flood frequency, we can also perform a drought frequency analysis. We will discuss drought severity area frequency and drought severity duration frequency curve, that is SAF and SDF curves, and we will outline a stepwise procedure to construct these curves. So coming to the frequency analysis, the frequency analysis of drought occurrence is important because it quantifies the drought severity, duration and frequency for a given area, especially where droughts are more common. So there are several ways where we can do it. The first one is severity area frequency curve, that is called SAF. Second is severity duration frequency curve called SDF. And third is severity area duration curve called SAD. So these are the curves which are there. So the first one here you can see that this is severity, this is areal coverage A, and this is frequency. So that is an SAF curve. So what we can see in SAF curve, as your area increases, your severity decreases. So that is what we can find it out. For a higher return periods, that is where the frequency is less, then you can see that the severity is more. Next is your severity, duration and frequency curve, that is SDF curve. So here also you can see that as your duration increases, your severity is decreasing and the return period effect is also felt here. Now coming to the SAF curves, that is severity area frequency curve. So regional drought is assumed when there is a significant fraction of the total area of the region under drought. So why area is important? Because drought is a spatial phenomena. So if you consider a area, if drought is restricted to just here, it will not be alarming because you can pull up resources from the adjacent places. But what if you see that entire area is affected by drought, then pulling up resources becomes difficult because then you have to rely on external sources to pull up resources. So that is why how much area is covered by the drought is very important, and that we can analyze using SAF curves. So SAF curves would characterize the spatial extent, intensity and recurrence of the drought events, and it will help us analyze drought behavior across space and time. So what we require first is severity. It will quantify the intenseness or the prolonged duration of the drought. Area would represent the spatial extent of the region affected by drought in a given time, which is usually expressed as a percentage of the total study area. So if your study area is 100% and this much area is drought affected and this is not, then we find what is the total area. So that is why percentage area is important, and frequency would describe how much often it is. So based on this we get an idea that if the drought, the percentage area is less, then it is a localized drought. If the percentage area is more, it is a widespread drought, then that we can identify. So in SAF curves, this recurrence pattern is very important, that how frequently the droughts recur. So from this study we have taken this graph to show that these are the different SAF SDF curves they have plotted. Out of that, the event for 1987 and 1995 4-5 they were separately plotted to just visualize where they lie. So you can see that 1986 and 1987 they lie between 10 and 50 year return period, 10 and 20 year return period, while 94-95 lie between 20 and 50 year return period. So that is where these so what is the severity of that event, that can also be estimated. So coming to the steps, the first step is we'll identify the drought using any index which we are considering, either SPI, SPEI, SSI, at a suitable time scale. So that is the first. Next is we'll apply theory of runs to characterize drought. That is, we will find the drought characteristics like what is the duration, intensity and severity of drought. So severity is the important thing. Next, we'll find severity for varying areal extent. So we'll estimate the severity associated with different areal extents, like taking the area threshold. So if we take 10% area threshold, what is the severity? 20% area threshold. So in a way you are lumping for that area and you are accounting what is the severity if you go on expanding the area. Then you will find the best fit distribution to determine for the frequency analysis. Then you will perform the frequency analysis of the drought severity for different areal extent. So that is the frequency analysis you will perform, and you will find severity for different return periods. And lastly, you will construct the SAF curves by assimilating this information. So here is one case study. So this is from a study Sharma and Sharma 2023. So Western India is considered, Rajasthan, Gujarat and Maharashtra. So SPI is estimated for meteorological droughts and for different durations, and it is further used to calculate the SAF curves. So the time scales at which SPI was derived using a non-parametric approach, that is SPI 1, 3, 6, 9, 12 and 24. So here we define the drought where your SPI value was below threshold of -0.8. So that is a threshold used in several studies. Some studies use -1 as a threshold also. So it depends upon which study you are referring to, but both are acceptable depending upon their applicability. So the annual drought severity for each SPI is then derived at each grid point. So just going back to the previous slide, these all points represent IMD rainfall grids at 0.25 degree. So for each grid point, I'll calculate SPI at different different durations, and then drought severity will be estimated considering different area threshold. So area threshold is how much percentage of area is under drought given the total area. So this study took 5% area increment, so 5, 10, 15, 20 and that on, and estimated the severity and the drought severity for these thresholds and time were then fitted with probability distributions. The best fit distribution was chosen, and then parameters of the distribution were estimated, and finally the return period values were computed for 5, 10, 20, 50, 80, 100 and then they were plotted. So we can see here the SAF curves being plotted for different time scales. So this is SPI, I think this is SPI 1, then SPI 3, 6, 9, 12 and 24. So for different SPI time scales they were plotted. So because we have already seen what these time scales refer to, if 1 to 3 are shorter time scales, then 3 to 9 are like moderate, and 12 to 24 are longer time scales, that how drought propagates at that. So what we see that as the areal extent increases, the severity decreases. So if the increase in the areal extent, the severity is decreasing, that is very common. All the curves you can see they are following the same phenomena, except at SPI 24 where you can see that there is little bit abrupt slope. Otherwise all the curves are very smooth, which we can see for different return periods. So for a given areal extent we can see that how the drought severity can be, and that can be gauged from this SAF curve. There are other case studies by Mishra and Singh which compared historical SAF curves with the future, which are derived from the GCM data. So the projected data was extracted from 6 GCM, it was then downscaled, and then again the SAF curves were derived and they were compared with the historical data to analyze the effect of climate change. One more case study where they showed the projected short term and long term droughts were more severe during 2001 to 2050. Again there are case studies which have estimated seasonal drought relationship using changes in SAF curve, and there are other applications as well which we can explore. Also, if you want to see what are the drought effects on the agriculture, you can estimate SPI 6 for Rabi and Kharif season separately. So your Kharif season is corresponding to your monsoon. So usually sowing happens in the end of May and it will go or early June, and then harvesting is in October. While Rabi season, your sowing happens in end of October or early November, it will go till March, and for this you can use SPI 6 for these seasons, and then you can estimate their SAF curves to understand what are the seasonal drought changes. Applications, we can use it for regional drought assessment, where SAF curves will help quantify the likelihood of drought with specific severity, and it will give the spatial coverage. This is very important. So spatial coverage will give us an idea about the vulnerable regions. We can do a comparative basin analysis, that what are the across multiple basins or climate zones, how the drought heterogeneity is reflected. Then we can use for infrastructure and water supply planning, that if in regional droughts, how severe these droughts are, then we can plan our reservoirs or irrigation systems or even groundwater recharging methods based on the severity of these droughts. We can also do climate change impact assessments, that if there are long term changes, if the droughts are becoming more severe in future, if we analyze using GCM data, then we can also see that what is a climate change impact, and ultimately we can prepare early warning system for drought preparedness, where for a given drought aerial coverage, what can be our mitigation plans that we can design. Next is SDF curves, that is severity, duration, frequency curves. So they provide a different perspective. Earlier they were on severity area, now they provide severity and duration. So how long this drought severity is being experienced, that we can find it out. So they are more valuable when we are assessing the drought risk. So if you are looking more into agriculture risk, so if the drought duration is longer, let us say if it goes from Kharif to Rabi season, then what can be the risk and all, so that duration perspective comes into picture. So what are the steps? First step, you compute the monthly drought severity using any meteorological derived indice. It can be SPI, SPEI or other indices. Then you derive a threshold. So some studies consider 0 as threshold, then some as minus 0.8, minus 1.0, so there can be different threshold. Then you can compute the drought severity for different series like SPI 1, SPI 3 and so on, as we discussed earlier. Then you can fit the various probability distributions. What is the best fit distribution can be found out, and then we can plot different return periods, that how the things would behave. So there are some studies which have shown that SDF relationships in Greece using extreme value distribution, where they prepared ISO severity maps for different return periods. Then Sagafin et al. Analyzed droughts in Iran using theory of runs to derive SDF curves, and again prepared ISO severity maps. So here you will have duration, here you have severity. So you can see that this type of characteristic behavior will be there. So this is for different return period. Also people have explored like empirical or semi-empirical relationship like plotting position formulas to model this. So as a substitute of your frequency based or probability distributions, they have used this plotting position as well. Then Janga Reddy and Ganguly also presented a copula based multivariate probabilistic approach to model SDF. So they have used a multivariate approach which use this probabilistic framework to derive this. Then again point rainfall observations can also be used to derive SDF curves. because where you can use location based data which are more specific rather than an average based gridded data. People have also explored the role of partial duration series, where they apply certain threshold to precipitation instead of using SPI in computing drought severity, because SPI does what it is like taking a standardized variable. So rather than that, directly to precipitation they apply certain threshold. Let us say if the precipitation less than 10 millimeter, they can classify it as drought, and then using those series then they can model it as a partial duration series to derive the SDF curves. Then there is another study by Adarsh et al. Which use bivariate copula for deriving SDF curve in Kerala. Then some other studies use multivariate standardized drought index, which will simultaneously evaluate how precipitation and soil moisture deficit conditions are used for deriving copula. So we have already seen what can be compound events. So here the compounding effect of precipitation and soil moisture deficit both are considered, and then you can incorporate drought relationships. So what are the applications of this? So SDF curves provide essential input in designing drought resilient infrastructure like reservoirs, water supply system and irrigation networks. So if there is a seasonal drought, so how your reservoirs in how your reservoir storage should be managed in case of a seasonal drought, then this is very important to address. Again, your water supply system, if it is a continuous system or an intermittent system, then how the storage water flows can be regulated, that can also be considered when you are taking seasonal drought into assessment. Next is assessment of drought return periods. It will quantify how often droughts of given severity and duration are expected, which can help us in long term resource allocation as well. That a certain region is more affected by long term droughts and which are also severe. So once they are long term but less severe, then you can mitigate easily, but if the duration is also longer and severity is more, then mitigation is a challenge. So that resource allocation for as a preemptive measure to counter the drought is also important. We can also compare the historical and projected characteristics to get an idea about what are the potential shift in drought persistence and intensity. Also we can evaluate water availability during prolonged dry periods, and which can help us plan our agriculture infrastructure better to tackle future drought risk. So if you know that droughts are being longer, you can use alternate techniques of irrigation like sprinkler or drip irrigation, which are more water saving rather than flooding, and that can help us lower the drought risk in future, because in certain regions it is very difficult to provide water sources to overcome this issues, and that is why the only solution is that we turn to more adaptive measures rather than foreseeing such risks. What are the key takeaway from this lecture? We explored drought frequency analysis. It quantifies drought severity, duration, areal extent and its recurrence, and thus provides a statistical foundation for assessing drought risk and its spatiotemporal variability. We looked at detail of severity area frequency curve and severity duration frequency curve, which collectively describe the spatial extent, temporal persistence and recurrence of the drought behavior. These curves will help us in drought risk assessment, water resource planning, climate change impact analysis and agriculture management, and thus enabling us for effective mitigation and preparedness. What is an activity suggestion for you? You can present a comparative assessment of the practical importance of SAF and SDF curves and how they can be more effective for various applications, like if you want to consider risk assessment, whether SAF is much better or SDF, resource planning which is better, or agriculture management which is better. So you can just prepare a comparative assessment of that. These are some additional reference material where this is a book chapter which you can refer. There are some research articles which will give you a better idea of the application of SF and SDF curve. This is one of the very earliest papers which have been reported by Mishra and Desai on SF and SDF curves. Thank you for your attention. We'll meet in the next lecture to discuss drought propagation and transition. Thank you very much.